For 12.8, parabolic modeling with word problems, we're going to be given word problems and we're going to be given some sort of quadratic and we have to answer questions about it. So right now, go ahead and pause the video so everyone can copy down the question. Let's go ahead and read through the word problem together. I am going to have us underline and circle keywords. A manufacturer of lighting fixtures has daily production costs modeled by P of x equals 0.25x squared minus 10x plus 800. I'm noticing that we have an x squared here, so it's a quadratic where y is the total cost in dollars. So it's the cost, and our units are dollars. X is the number of fixtures produced. So x is number of fixtures. Let's go ahead and look at the first question. What is the cost for 10 fixtures to be produced? Now they're giving me the number of fixtures, so they're giving me an x value. And we're asking for what is the cost? Well, cost is the y value. So our answer is a y value. For A, we're going to take 10 and we plug it in. So P of 10, my model at the value of 10 is 0.25 times 10 squared minus 10 times 10 plus 800. So we plug this into our calculators. 0.25 times 100 minus 100 plus 800. That's going to give us 25 minus 100 plus 800. So this is 725. For part B, it's asking what is the minimum daily production cost. So minimum costs are two keywords there. The word minimum implies that we're going to find the vertex. And the word cost tells me that my answer is a y value. I look at my model. I'm in standard form. So to find the vertex, we're going to use negative b over 2a. So negative, my b is negative 10 over 2, my a is 0.25. Go ahead and plug that in the calculator, and you should get 20. But remember, this is my x value. To find my y value, I then plug it in. So let's go ahead and plug it in. 0.25 times 20 squared minus 10 times 20 plus 800. 0.25 times 400 minus 100 plus 800, and we get 700. So our vertex is 20, 700. For part B, our answer is the y value. The y value is a cost, so our answer is $700. For part C asks how many fixtures should be produced each day to yield a minimum cost. So again, minimum tells us we're going to look at the vertex. How many fixtures tells us that our answer is an x value. So what is the x value at the vertex? Well, we already found the vertex. The x value is 20, so C is 20 fixtures. Here's our second problem. Go ahead and pause the video so that the students can write it down. Now that you've written it down, let's read it together. The path that a diver follows is given by y equals negative 0.4 x minus 4 squared plus 14, where x is the horizontal distance in feet from the edge of the diving board and y is the height in feet. So again, I notice it's a quadratic. X is our horizontal distance from the diving board. Y is the height. Our first question asks, what is the maximum height of the diver? Well, maximum implies that we're going to be looking for the vertex. Height implies that I'm going to be looking for a y value. Let's look at our model. We're in vertex form. That means that our vertex is opposite, so 4. And then here's my k, 14. So remember again, it's opposite h, k. Negative 4 is the opposite of h, so h is 4, k is 14. To answer the question, what is the maximum height? Height's our y value. Our y value is 14, so the answer is 14 feet. For part B, how far from the diving board does the diver hit the water? So we want to hit the water. And it's asking how far from the board. Well, distance from the board is an x value. Now we have to figure out this hitting the water. So if I'm picturing a diving board and some water as my graph, my diver dives, I hit the water. This point is an x-intercept. Or you can think that it occurs when y equals 0, or my height's my y, is 0. So we're going to make y equal to 0. 0 equals negative 0.4, x minus 4 squared plus 14. We have to solve for x. When we're in this vertex form, we're undoing order of operations. I'm going to subtract 14. Divide by negative 0.4. I get 35 equals x minus 4 squared. Take the square root. Whenever we take the square root, we're plus or minus. Now, when we're in a real world situation, we're actually going to write out the decimal. So this is plus or minus 5.9 equals x minus 4. When we add the 4 over, we get x equals 4 plus or minus 5.9. So x equals 4 plus 5.9 is 9.9. 4 minus 5.9 is negative 1.9. In a real world situation, we're not going to have a negative answer. So our answer is 9.9 feet. So this is 9.9 feet away. For question 3, go ahead and give the students time to write down the question. Let's go ahead and read the question together now that you've written it down. An object is thrown off the top of a building. The path it takes to the ground is modeled by, I'm going to go ahead and box our equation, where t is the time and y is the corresponding height. So y is height. Let's go ahead and read part A. At what time does the object reach its maximum height? So what time? Time is t, so it's a t value, or if you want to think of an x value, it's an x value. Maximum tells us we're thinking of the vertex, so we're going to find the vertex and whatever the t is. We're in standard form, so we're going to use negative b over 2a. B is 32. A is negative 16. So we have negative 32 over 2 times negative 16. That's positive 1. I could keep going, but this is my x value. This is my t value. So my answer is 1 units are second. For part B, the question asks, what is the object's maximum height? So again, maximum refers to the vertex. Height refers to the y value. So we want to know the y value of the vertex. Well, our t value is 1, so we're going to take 1 and plug it in. Order of operations, exponents first. 1 squared is 1. 1 times negative 16 is negative 16. We get a positive 32, a positive 128. I get 144. So my answer is 144. My units are feet. Let's look at part C. How long does it take for the object to hit the ground? When I'm looking for how long something is, that's saying I want time. So my answer is a t value. When I hit the ground, so here's my building. Let's go ahead and picture it. Here's my building. My object is thrown. When does it hit the ground? Well, when I hit the ground, let me go ahead and write that differently. My height equals 0. Well, height is a y value, so y equals 0. Let's make y equal to 0. 0 equals negative 16t squared plus 32t plus 128. This is a solving problem. I'm in standard form equal to 0. So we can factor. We can complete the square. We can use quadratic formula. Before I try any of these, I'm going to divide everything by negative 16. Whatever I do to one side, I do to the other. Make sure to make this opposite, minus 2t. Make sure to make that opposite also, minus 8. This does give me a factorable polynomial, t, but you can use one of these either two, but I'm going to factor. Let's see, minus 4 plus 2. Let's check. That's minus 4t plus 2t. That gives me minus 2t. So this means my answers are t equals 4 and negative 2. Real world problems don't have negative solutions, so my answer is 4 seconds.